Good evening, friends. Now, slowly I will switch over from electrical TRD to electric locomotives. This is the juncture of TRD overhead power supply system with locomotives. We are taking power supply from the grid supply substation in three-phase form. Then in the traction substation, we are using two phases, step downing it to 25 kV. One end is given to the OHE and another end is grounded solidly earth and connected with the railway track. So it is working as single phase system. The OHE is the phase and the ground is the neutral. It is just like our home appliances single phase system, phase and neutral. From the overhead system, the pantograph is collecting the current. There is a vacuum circuit breaker. If you will close it, then the power supply will go to the main winding of a transformer inside the locomotives. From the loco, it is getting 25 kV, but another end is at neutral voltage. That means it is connected with the ground with the help of loco body, wheel and track to the traction substation grounding point. So the track is working as neutral or ground. The 25 kV we are receiving from the pantograph and this 25 kV is fully dropped, and the other end of the winding is at ground potential 0 volt. That means fully across this winding that is 25 kV approximately. It may vary. Now from this main winding we are taking near about 650 volt supply, and with the help of bridge rectifier we are converting it into DC. Then we are giving it to the DC series motor in the previous system where we are using DC series motor as traction motor. Three motors in each winding of the secondary of the main transformer of the locomotives, and it is voltage around 650 volt. So two sets of diagram is shown, two sets of bridge rectifier, and this is the system. So 25 kV in the locomotive step down to 650 volt. But with this main winding, another winding is there. I'll show it later, which runs the three-phase auxiliaries. The voltage is around 380 volt. 380 volt. Another winding is coming, but from this single-phase system, we were converting it with the Arno converter or some other means, and this three-phase supply is given to the auxiliaries of the locomotives. Auxiliaries means this traction motor is taking tremendous current and it needs help. Not only the traction motor, the rectifier is also going to be heated. The transformer, the smoothing reactor, that means this inductive coil, all are getting heated. Then the transformer oil also need cooling. So all these function we are doing in these auxiliaries motors. We are using blower motor. We are using blower motor, silicon rectifier, blower motor. So many blower motors are there. Then you know our controlling circuit is working with 110 volt DC, but we cannot work directly to this power circuit. That means this 650 volt and everything. So what we are using? We are using electromagnetic relays or electro pneumatic contactor, so that we cannot directly contact with the power circuit in live condition. Dead condition, the system in electrical is you can work with the power circuit, but you need shutdown. But during live condition, you shouldn't touch this power circuit. You shouldn't touch this power circuit. So now inside the locomotive switch is available, that will I'll tell you step by step how it is functioning. First the DC motors, then our new system, the 3-phase induction motor in the traction motor. Okay, so this is the system. Again, if I repeat it, we are getting 3-phase supply from the grid substation, and with the help of transmission line we are receiving it in the traction substation. From there we are taking two phases. Here we have shown red and yellow, and then it is connected with the single phase transformer, two phase incoming, but it is a single phase transformer. We are stepping it down to around 25 kV, but the voltage must be 27 point less than 27.5 kV maximum, and minimum also some limit is there, that is 22 point something in the traction substation. So this is this thing we are receiving in the traction substation, and what a beautiful we have done in the traction substation. One phase, the yellow phase, we have earth connected to ground. So many people are confused, sir, phase to earth, it will be a short circuit. No, it will not be a short circuit. What is short circuit? Short circuit is to complete an electrical circuit without any load, without any impedance. So that is short circuit. But here you see the secondary of the 25 kV one is connected to the ground. So this yellow phase will attain zero potential, and the other end red phase will be at around 25 kV. It is also stabilizing effect. If you keep one end at 0, the other end will be 25 kV around. It is a stabilizing effect. Stabilizing it, like working just like keep the voltage around 25 kV. But then it is going to the OH. But if you don't connect with, if you connect it with the load, then it will not be a short circuit. Suppose it is connected with the locomotives, then it is, when this circuit is complete with through a load, it will never be a short circuit. But if OH will fall on the ground, there will be no load. Directly OH will touch the ground, and it is without, circuit is completely without the load, so it is a short circuit. But here, when there is OH and there is no locomotive, then it will act as open circuit. It will never be a short circuit. Keep clear idea about the short circuit. Short circuit is that thing to complete an electrical circuit without load. Our system is I is equal to V by Z or V by R in DC system. If your Z is not there, if your R is not there, enormous current will flow. Okay, that is Z or R, that is giving opposition to the current. So it is controlling the current. But if you have no resistance or impedance, it will go, the current will be enormous. Okay. Then this phase we are giving to the pantograph to transformer, but through an insulated path, so that body, it should not touch body of the locomotive. the body of the locomotive is in ground potential. You see, the body, metallic body of the locomotive is in ground potential. If you directly touch with the body, it will be short circuit, face to ground. So we are using insulated path to come to the transformer inside the locomotives, and we are receiving this 25 kV from the roof of the locomotives, and the other end is connected with the body through some arrangement, through some resistance, through some switch, so many things. I'll discuss it later. But the body is in ground potential. You see, the top portion is through the insulator, but the bottom portion, that is zero potential, it is connected with the body. So it will not harm, because the body is fully connected with the wheel to the railway track, which is in ground potential. So the whole locomotive body is in ground potential. If the OHE will fall on the locomotive, then the system of the current, that it will follow the low resistive path, low impedance path. So your body will not get shocked. The current will flow through the wheel to the circuit breaker, and our circuit breaker is so fast, within a few seconds it will trip the circuit breaker and power will be switched off. So many things, and so people are thinking, sir, if the whichever fall on the boggy or electric locomotive, will we get shock? No, we will not get shock due to the law of the electric current. It will follow the low impedance or low resistive path. It will not come to your body, as the loco body is in ground potential. Loco body is in ground potential. Now from the main transfer of the locomotive, we have taken two bridge rectifier circuit at 650 volt, and after smoothing reactor, this conversion of the DC voltage is generating ripple voltage. The AC, we are converting it to AC, but it has some ripple, so it will be reduced by the smoothing reactor. According to the law of the inductive coil, the voltage will induce in it when there is a change of current or voltage. Then it will oppose that very cause. The cause is the variation, so it will reduce the variation of the current or voltage. So we are using smoothing reactor to make the DC current more smooth, and then we are applying it in the traction motor, DC series motor. DC series motor, the motor is rotating and it is coupled with the wheel, with some arrangement. I will tell it later, and the wheel will rotate. The wheel will rotate. And another supply you have taken, I have already told, we have taken another winding for auxiliaries. It is taking, we are taking 380 volt, here 650 volt, and there is 380 volt. Then we are converting the single phase into three phase to run three phase induction motor as auxiliary motors. Auxiliary means it will help this traction motors operation, all assisting equipment like transformer, main transformer, cooling, main transformer, blower, then smoothing reactor cooling, silicon rectifier cooling, traction motor cooling, then your brake system compressor, that is in the 380 volt system, auxiliary system. It is creating compressed air. Compressed air, why you are using? Because compressed air used for locomotive brake as well as the electro-pneumatic circuit. All our power circuit almost controlled by this electro-pneumatic circuit. That means if you on a switch, it will open the port of some with magnetic attraction to enter air pressure, and this air pressure will close the contactor. the air pressure will close the contact. This is electromagnetic, electropneumatic. Then there is some electromagnetic, but in our OHG system we are using electromagnetic mainly. No pneumatic system almost not used in our traction system. Some circuit breaker and they have used in the earlier stage, but now we are using tripping coil and closing coil. This is electromagnetic for the circuit breaker, and all other controlling relay, everything we are using this 110 volt DC. So traction substation is 110 volt DC, but they are not almost using pneumatic operation, electromagnetic mainly, and the locomotive is electromagnetic as well as electro-pneumatic. Pneumatic means air pressure. Pneumatic means air pressure, compressed air pressure. So now we'll switch over step by step to the locomotives. Okay. And any question in connection with the TRD, you can ask me through my mail address. Okay. Thank you, friends. Good evening, friends. Now